All right. Hey, everybody. My name is Bryce AC. I am a public health employee, and I have a background in machine learning and data science. And I'm joined today with Scott and Nicole, and they're in the same boat we are. And I just thought we would live stream our journal sessions for anyone who's trying to learn data science within public health, and hopefully this helps you out. So the first thing we're going to do is we need to find a data set that we want to practice and working on. There's two main popular data sets that people use. The first one, when they first start out, the first one is the iris data set. And this one is super popular. It's kind of the hello world of machine learning. And we're going to be using a website called Kaggle to access a lot of these data sets, and we're going to be going through and finding them. So the iris flower data set I have it pulled up right here, is a CSV, and CSV stands for comma separated values. And the way it works is you have each of your columns with each of the variables that you're hoping to use in the analysis. So here they have the sepal length, the sepal width, the petal length, and the petal width. And then here are the classifications that they have for it. And so if you see here, we have setosa, versicolor, virginica, and those are the three. And so this is a pretty small data set. People use it a lot. And the nice thing about this data set is that it's already cleaned. There's not any issues with it. It's a very beginner-friendly data set. We're going to try to find one that is not as clean, so that way we can work through the entire process of exactly getting real-world data and what you have to do with it. So here, we're going to click on Data, and there's a huge repository of data sets on Kaggle. So if we scroll down, and Nicole and Scott, feel free to jump in if you see ones that you think would be a good one to start out with, and we can take a look.
So I didn't dive too deep into it, but I did look at the heart attack analysis data set, and that one looked interesting.
Okay, let's take a quick look at it, because I saw that right there. Okay, let's take a look. So here we have the age, the sex, chest pain, resting blood pressure, cholesterol, fasting, resting ECG, maximum heart rate. Okay, so this is actually a pretty good data set because you can see it's pretty clean. There's not a whole lot of missing data. Yeah, I would say this is a pretty good one. The only thing that I would think about is if they had, let's download it really quick, and let's see if they have a control in there, or if it's just heart attack data. Because normally, in order to compare things, you have to have some sort of baseline to go off of it. So I'm wondering if they have any classifications, or if this is just people who've had heart attacks. I'm guessing, I don't know, do you guys see if they have one, if it's an output, if it's a classification or not. I'm guessing it's this output.
Yeah,
Yeah.
let's see. It's not in the description anywhere, is it? No, I don't see any description really.
Well, they have target right here, so less chance of a heart attack, more chance of a heart attack. But I don't think it actually says if they had a heart attack or not.
Do you think the other file, the O2 saturation, would? Oh, never mind. I can look at it. Nope. It doesn't seem to have anything except for what the O2 saturation was.
Yeah. Because I'm looking out here, and I'm not seeing. So I'm guessing this is the phthalate, right? And then, yeah, this isn't matching up. Like,
Okay, so
what we downloaded isn't matching up with what they have shown.
maybe it's a bad data set to use then.
It's not necessarily a bad one. I think we would have to, I'm guessing it's this output, because generally when you do the output, if it's a binary one, they'll give it a 0 or 1. And so I'm guessing that this target is actually the output. And
Yeah,
so,
I think so.
and so I think what they're saying is that there's less chance of a heart attack if it's 0, and more chance of a heart attack if it's 1. So these are the
Okay.
people. So I think the hypothesis is here that we could say is, are you high risk or not with that, or the goal would be to determine that. And so there we'd have a binary classification of low risk, high risk, and you're trying to separate people out on that. This is a pretty small data set. It's not bad, but it's 304. So that will limit on what type of machine learning problems we can use. But for many applications of machine learning, this should be fine depending on the quality of the data. And so far from what I'm seeing, I'm not seeing anything too crazy. So we'll keep that one on the side burner of a potential one. Okay. I can pull up one that we bookmarked earlier. I don't know if I remember how to access my bookmarked.
I was going to ask you that because I bookmarked a few yesterday and I wasn't sure how to access them.
So I just went under datasets and then bookmarks.
Oh, okay.
Yeah, so here's one we looked at the other day. And let's do, I think I already downloaded that. We can talk about why this is, oh, pretty sure I downloaded it. Maybe I didn't. So this is a CSV file that they have. And if we download it, let's take a quick look at what they have. And so this is data that was uploaded for, come on, computer, I know you can do it, for ALS, and it's the DNA samples for that. And going through it, so these are all, what we kind of decided to set up was that they saved this as a CSV when they shouldn't have. These are semicolon separated. And they put in other information right here. And so going through it, if we were to separate these out and read them in, it would think that this first column, the Coriel order ID, would be 0 equals none for that. And so we have to clean up this data set a little bit. Pandas within Python has an option that we can separate on these the semicolons, but we can also convert it over to a CSV as well. We can iterate through it and just change it, just do a replace function and replace all these with commas, and that should work too. So we could delete this first part out and get these. Something that I think a lot of data scientists don't realize is that with Excel, I really like Excel for some of the exploratory stuff, like viewing data sets, because it's super easy. It doesn't take any lines of code, and you can just open it up, and you can do some basic data manipulation if you have. It's a good visual way to do it. And so if you're starting out with data science, don't be afraid to be like, oh no, I have to do everything programmatically now. You can use other tools as well. Just looking at this data set, these are all positive samples. And so we have no controls to base it off of. So if we wanted to use this data set, what we would have to do is we'd have to get a bunch of controls of normal people who do not have the disease, from what I can tell anyways. I don't know, because if we're looking at the so these are all positive samples on here. So if we wanted to do any type of algorithm determination, we're going to have to create a second data set of non-ALS samples to compare it to. One of the problems with this too is you could see in that last data set, the stroke one that Scott suggested, it was really nice because it explained, like there was some issues with it, but it explained exactly what each of the headers are for. And this one, they didn't really give any explanation. They just kind of threw it up there and said, there you go, and without any explanations. And that's kind of poor data practice. You need to make sure you're actually explaining your data set, because some of these things may not be completely intuitive. So going up here and looking at their columns, like, I'm not sure, like if you're not within the genomics realm and you're like you wouldn't be like, what's a Coriel lot, or what's a diagnostic description, or things like that. Like you wouldn't have any idea. And so it's important to put those in there and actually do a good job of that. One of the other data sets we look at that was kind of weird was this fetal health classification. No, it wasn't this one.
I think that one was interesting, right?
Yeah, this one was interesting. I was looking for the one where it was not any data set. They loaded up their paper.
Oh yeah.
And I was like, what the? No, this one was a good one. Some of the categories, I'm not quite sure why they put them in, because if you look at this severe decelerations, it's all 0. Maybe it's down lower. I don't know. But from what I just did my initial analysis, it was all 0. So that's not an important feature. And so if we were going to do an analysis on there, this would be one of the first things I would throw out, is because it looks like it's not actually contributing at all to anything. And they do have here a score that says fetal health. And if I remember, yeah, I don't think they give an explanation of, oh no, the three classes, normal, suspect, and pathological, but they don't give what those values actually are. So I'm assuming that 1 is normal, 2 is suspect, and 3 is pathological, but we don't know that for sure. And so that might be something we could tease out if we were to graph it out and see, oh, these values are way high or way low. Maybe from some of these we can figure that out. And because we have so many values within here, just like with these severe decelerations, I am assuming that all of them are not going to be important. So I would perform a data reduction, an event on here too, to reduce some of these values. So maybe we'll do like a PCA analysis, or we'll do an SVD, so single value decomposition, and kind of pull out all the important information out of there. And we also need to figure out if some of these are, what's it called? When two data points are connected with each other. So a
if like one's
correlation.
dependent on the other.
Yeah, like, so if, not correlation. Yeah, if they're dependent, like if these are dependent variables or if they're independent as well. Because if you find some of these are dependent, you probably don't want to keep including them. And so we'll need to figure out a way to combine them or take one of those out, so that way we're not having dependent variables associated with it. But it's kind of hard because they didn't give you enough information when they give the explanation about this data set. Like, it would have been nice if they would have given for each column, this is what's going on, this is why it's important, or this is, because one of the things we were looking at too is this histogram mode and histogram mean and histogram medium. These look like they're all related to, these would potentially be dependent on each other, but I'm not entirely sure. And so this just seems like meta-analysis data, but I'm not entirely for sure about that. And so it'd be hard. We'd have to make a lot of assumptions with this data set to actually be able to use it. And maybe if we read the paper, it would make more sense too for that. So maybe let's take a quick look at the paper. Where's the full article? Is that the full article?
Download PDF.
Oh. Oh, hopefully it's available for free. No.
Hold on. I still have my graduate school library access. Can you send me the link?
Oh, it's okay. It's not like a huge deal.
Okay.
But it's just weird that, well, so that's something in science that you'll find out, is that most scientific research is done with taxpayer money, but it doesn't mean the taxpayers actually get to see what's going on. Everything's behind a paywall a lot of times, and it's very expensive. Sometimes it's hundreds of dollars just to access one article for like 30 minutes. Mm-hmm. It's very, very annoying. So write your congressman and have them change that. But yeah, so this one might be a good one, but I just feel like we're missing a lot of information on what some of these are and how they came up with some of these categories and if they're important. So I don't know if anyone's watching me who's programmers are going to be cringing that I use. Where'd my Kaggle go? Internet browser.
Oh no.
I know. Let me get back into Kaggle. I don't remember exiting out.
Yeah, no luck with the paper. It is locked beyond UMBC's access as well.
Okay, let me look at my. So we looked at that one, and then we looked at this stroke prediction.
Oh, they have an infant and childhood mortality rates data set that looks like it's from the CDC.
Okay.
Can I put it in the chat link?
Yeah.
Okay, hold on. I'm curious to know what your opinion is of this data set, just because I think it's coming from the CDC, so you would expect it to be good?
All right, let's actually look at the. Sorry, I got distracted. Yeah, so looks like it's a pretty small data set. So they have the infant mortality, or childhood mortality, infant and neonatal, and infant mortality by race. So like with this one, this might be an interesting one if we were to do this and compare it like with public health policies that were introduced, or so like maybe we can do the analysis before 1960, before newborn screening was done, and then maybe compare it like as new disorders are introduced, like how that has effect. This wouldn't be really like a machine learning type problem, but maybe it can be a graphing show how this affects certain parameters, like how newborn screening impacted so childhood mortality.
Yeah.
So I wouldn't say it was like a great data set on its own, but maybe if we separated it out. Yeah, because they have it between 5 and 9 years old. Oh, I wish they had it for younger. Oh, 1 to 4 years. Yeah, they have it. Yeah, so we're in the newborn screening community. So this might be an interesting data set for us to go through and see how after 1960, when newborn screening was first came about, and then maybe we can figure out when each of the disorders started being screened for with treatments, and
Well, that'd be
see
interesting.
how that impacted it.
I wonder how big of a change we'll see, considering some of the diseases are like really rare. Like for instance, if we do galactosemia, whenever galactosemia was introduced, I bet you we'll see a reasonable decline. But then if we look for like one of the LSDs, I wonder if that'll really make a big impact.
Yeah,
Yeah.
for sure. Yeah, this would be a good one to like. Yeah, take a little bit of work for us, like detective work, to put some of that other stuff together. But it might be worth at least for our field, it might be worth
Hmm.
a look into. Do some of the basic data science behind it. So here's the rates by race. So this one might be interesting to do. Um, maybe we can compare it to, we can look at the income inequality between the races. So like income inequality levels for white people during these years and income inequality for African American people during those years, and see if there's any correlation associated with that. So, and maybe even make predictions of like, use this as a small data set, maybe do like a random forest or something to be like, or no, we'd have to do some sort of regression, but just say if income equality is at this level, this is infant mortality levels or things like that, and see if there's any correlation associated with those. But yeah, that would be a good one. I don't know. How do you guys feel? Do you think these ones might be like? Do we want to do some more research next time and see if we can find some of that other data somewhere?
Yeah, I'd really like to do the infant mortality based on the discovery of newborn screening techniques.
Uh huh.
Even if it's just like 3 or 4, we could do 3 or 4 time points. Time point 1 being PKU, the first one that came out, and then
Yeah.
a big one like galactosemia, which is one technique that determines multiple types of galactosemia, and then what's another good one? Tyrosemia, or any of the acidosemias
Yep.
from tandem mass spec.
Yeah, no, I think that would be interesting. And maybe we could see like a delayed, like I'm curious too if there's like if we can predict like how long it takes once one of these disorders are like if we do see a reduction down the road, like if we can predict once a new disorder is implemented, how long it takes before we start seeing reductions.
Yeah, I think that'd be really
Yeah.
cool. I apologize. I got an experiment that I got to get back to, so
Oh, no
I
worries.
gotta
So
Oh,
leave.
we got a late start. So, well, thanks, guys. So,
Yep.
thank you.
all right,
Bye.
bye.
Bye.